Today we are going to study and plot the speed torque characteristics of DC servo motor. And apparatus required the servo motor, trainer kit and digital meter. And you can see the procedure here. There are 10 points. According to procedure, we must do two type of tabular column. One is to measure the DC servo motor speed control, and another is giving the load to control the speed of the motor. And you must take the speed in RPM and current in amps and back EMF in voltage. We use voltmeter, that is DC voltmeter. For that we use multimeter. And this is the DC servo motor speed control demonstrator kit. We are now going to use this. So this is power on switch, and you can see the armature current. See armature current here, and you can see the speed in RPM in this display. And this is DC servo motor on off switch, that is S1, and for that you can use this knob to vary the speed. You can see DC servo motor speed control knob. And S2 is to give the switch on the load motor, S2. And for this you can see the load motor speed control switch. You can see there is some mark. And to measure the back EMF, that is in voltage, you can pin here the multimeter. This is positive side of the multimeter, and this ground, this negative side of the multimeter. And this is a simple diagram. It is given. You can see DC servo motor, this, and this is load motor. It is coupled here, and this is toothed wheel. It is coupled here. This is coupling, and DC, here is variable DC supply for DC servo motor. Okay. This is optocoupler, and you can see this is load motor. Okay, to give the load, and for this variable DC supply for load motor. And this is the full kit diagram, how it is connected. But for this experiment it is not important, but I am showing you how they are connecting the full kit inside motor, that is DC servo motor, and giving supply, all this. And this is tabulation 1. We should write the speed in RPM, NN, and B back EMF here. This is observation table number 1. Now going to the experiment. The power on switch is already in on position. Now you on the DC servo motor switch, and turn the knob in clockwise direction. So the motor may run. Motor will be running. You can hear some sound. This motor is running, and you can see the RPM is 2400. You can take as 2400. So you take as 2400 and you can see minus 5 point, the back EMF is minus 5.220, you can write 5.20. Now turn the DC motor speed control knob in anti-clockwise. So you can write the speed as 2300, and the back EMF is 5.00, minus 5.00. Next we adjust the DC servo motor speed control knob in anti-clockwise direction, and we have set the motor speed to 2200. You take as 2200, and the voltage back EMF is 4.80. Now the same way the DC servo motor speed control knob is adjusted, and you can write as 2000 because it is oscillating, so you write as 2000. The speed in RPM is 2000 and 4.45. So the first table is, we have taken 4 readings. For 2400 RPM you are getting minus, back EMF is minus 20, and for 2300 minus 5, for 2200 you are getting minus 4.80, and for 2000 you are getting back EMF is minus 4.45. Going to tabulation 2 and the procedure 2, that is you are going to give a control the speed of the servo motor by giving a load, fixing a load motor and controlling the speed. For this we have to calculate armature current, speed in RPM, voltage, power and torque. Now you keep the motor in maximum running condition. So the maximum running condition is 2300. Now switch on S2, that is load motor. Switch on load motor. Now slightly vary the switch. You can see the RPMs you can write as 2120, and take the armature current as 16. Now you increase the load. So the speed is, you can write as 1900, and the armature current is 0.074. Now by increasing the load you can take the speed in RPM as 1700, and you can armature current equal to 0.151. Now increase the load. So you are getting, you can write as 1650 or 1670. Now you can see the tabulation to speed in RPM is 2120 and current also taken. You can see this speed. For the rated speed we have got the armature current like this. The formula used is torque equal to 1.019 into P divided by 2 pi n gm centimeter, and power P equal to IA into volt, that is in watts, power in watts, and IA means armature current. By using the torque formula and power formula we have solved we have found power and we have found out torque. By using this we can plot a graph, and this is the model graph for DC servo motor speed torque characteristics. Here torque and speed, you can draw the graph. Thus the speed torque characteristics of DC servo motor is studied.